Hello, everyone. Welcome to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, University of Albany, and Seth's brother Joel. We're here to hopefully show you how to approach SAT math questions. Here's a math question from a calculator section, and let's go. We have this dynamic pressure, and then please pause the video, try it, and then come back. Pressure Q generated by a fluid moving with velocity v can be found in this formula. Yn is the density of the fluid. A person uses the formula to find the dynamic pressure of a fluid. Now I got to pay attention. Moving with a velocity v, and the same fluid moving with a velocity 1.5 v. What is the ratio of the dynamic pressure of the faster fluid to the dynamic pressure of the slower fluid? Now, Seth, let me start. Basically, if you know how to do this question and you've seen this question before, the answer is 1.5 squared, which is 2.25. So if you're lucky enough to know how to do this question, you can do this question in about 3 or 4 seconds. Many people may have seen this question because teachers love to ask this question. They love this question. So you may have seen questions like this. It's a similar thing, like if you double the dimensions of a square, how much does its area go up? Things like that. So that's the answer. Now the question is, how do you do it a little slower if you're not sure?
All right. So should I take a try at that?
Why don't you do it your way, and then I'm going to do it my way.
Okay,
and
so I'll do it my way.
Maybe they're the same way.
Well, okay, let's do it. Let's see. Okay, so well, again, read the question and identify what is the what are they asking for? That is the ratio. So what they're asking for is ratio given up here. Okay, now ratio is obtained by dividing two things. The top, the numerator, is a critical thing to know about ratio is 2. A over B is the ratio of A to B. Okay? So the 2 is the pressure of the slower fluid. The pressure of the slower fluid is, write the formula, N V, 1/2 times N times V squared. The pressure of the faster fluid has the same density properties, but instead of V, it is 1.5 V. And that is its velocity, and that's squared. So this is the answer. Great. So what you can do is cancel like crazy. Okay. 1.5 V. Let me use the eraser. Oh,
okay. A little bit too much.
I know. Erasing doesn't work. Erasing doesn't work here. So what is it? So this is 1.5 squared times N squared. And in the denominator, we have N squared. The N squareds cancel. And there is your 1.5 squared, which is what Joel...
The V. You made a small
I'm sorry, yeah, there's V squared here. 1.5 times V squared cancels with unit times V squared. The V squareds cancel, and the answer is 1.5 squared, just as Joel said.
Guess what? That is absolutely the way I would have done it as well. So that's really a very, very, very standard, reasonable approach. You have to know one rule about exponents, that AB to the n power is A to the n, B to the n, right? We used that little rule here when we went 1.5 V squared is equal to 1.5 squared times V squared. It's this rule of exponents, okay? You have to remember that rule.
Yeah.
Yeah, this is the standard way of doing it. Yeah. So either you know how to do it, or either you've seen this question before, you sort of know what to do, or you do it this way. But this is the standard way of doing it.
Well, there are lots of formulas in high school math that express this square dependency, like the area of a figure, like a circle or a rectangle or square, the area of a plane figure, how it depends on some measure of its length. Has a form, the area equals some constant times the square of the length. Yeah.
Right.
And
that's right.
Yeah. And in particular, the area of a square is is 1 times the square of the length.
Right.
Yeah. But a familiar formula in that they may pull out the SAT, which nominally looks like this, believe it or not, is the formula for the kinetic energy of a body with a given mass at a given velocity. And that formula is the kinetic energy is 1/2 of m times v squared.
Where m is the mass and v is the velocity.
Where m is the mass and v is the velocity.
Right. Right.
Which is that relationship in physics is sometimes used in publicity to encourage people to drive their cars at safe speeds.
Right.
Because the speed increases, the kinetic energy carried by the car and the passengers increases by how much the ratio of velocity of speed is squared. Right. So if you say, this example, the velocity, if you go 30 miles an hour is a speed limit. 45 miles an hour is an unsafe speed in a 30 mile per hour zone. Well, 40 miles per hour is 1.5 times 30.
45 miles an hour.
Yeah, 45. But the amount of the amount of kinetic energy is in this same as this problem. It goes up by a factor of over 2.
Right. Even though you only go like 15 miles an hour more, which doesn't seem like that much, you're doubling the damage in a car accident. Yeah.
Well, even worse, say 5 miles per hour versus 10 miles per hour.
Yeah.
The speed doubles. It goes up by only 5 miles per hour, and it doubles, but the kinetic energy goes up by a factor of 4.
Right.
Yeah.
Okay, so I think we're done here, right?
Yeah.
I think we're done.
Done.
Okay, so hopefully you've seen this type of question before. Very often you see it in geometry related to areas and changes in volume for pyramids and things like that.
Well, for volume, it would be a cubic.
For volume, it's a cubic. In physics, you see it in terms of radiation, right? Isn't there some sort of radiation formula?
The inverse square law for radiation, yeah.
Right. There's something to the cubic also in radiation? Maybe not. There's something to the cubic.
Inverse square, but there the exponent is -2.
Right. Yeah. So it goes down. If you're twice as far away from someone, you get 1/4 the radiation.
Yeah.
Okay, I think we are done with this. So have a great day. Please like us, dislike us, give us comments. Hopefully give us comments on how we can improve approaching SAT math questions. And hope to see you next time. Take care, everyone. Bye.